In this video, we're looking at 8.4 still, and we're looking at the product of a sum and a difference. So that's a fancy way of saying we're looking at two binomials that are the exact same, but one has a plus and one has a minus. And you guys are going to really love this one because the formula for that is simply a squared minus b squared. And so when you see the product of a sum and a difference, and you happen to remember this formula, then you don't have to worry about distributing. And so looking at number 11, I see, okay, I have two binomials that are the same. One is minus, one is plus. So I know it's going to just be a squared minus b squared. And a is going to be the x value, and b is just 5. We're not taking the signs in front. So that literally just translates into x squared minus 25. And that's it. That's the beauty of these problems. So then in number 12, again, I identify that they're the same. One's plus and minus. 2x is the a, and 3 is your b. So I use the formula a squared minus b squared. If a is 2x and b is 3, then that leaves me with 4x squared minus 9. So hopefully at this point you're kind of like, oh, I get this. I can probably try the next one on your own or on my own. So why don't you go out and do that? So in number 13, again, they're the same. One's just plus and one is minus. So I can use that formula a squared minus b squared. And my a value is 3x squared. So I'm going to actually show my work for this one just because that there's a power to a power here. And then my b value is 4. So that 3x squared all raised to the power of 2 is going to change to 9x to the power of 4. And then 4 squared is 16. So then try number 14 on your own. So again, we've got a squared minus b squared. My a is 5x squared. I'm going to square that. And my b value is y squared. And so your answer should be 25x to the power of 4 minus y to the power of 4. And finally, number 15. So again, there's your a, there's your b, and we got the formula a squared minus b squared. If I square 6w squared, that should give you 36w to the power of 4 minus, and then 8x squared is 64x squared. So the last part of your notes is just kind of like a mixed practice because I want you guys to be able to identify these special cases when they're not kind of just like in isolation. So I'm going to do these problems and you pause the video as you deem fit and then kind of check your answers as you go. So for number 1, I'm going to distribute the 2x squared to everything. So there's no formula here, but that gives me 6x to the power of 4, 8x to the power of 3, and 6x squared. Number 2, I've got repeated distribution here. So I got to distribute the 2x to everything. So I'm going to do that first. So that gives me 2x to the power of 4, 4x to the power of 3, and then 2x squared. And then I'm going to distribute the negative 1 to everything. So I'll go ahead and do that next. And remember, I like to kind of line up my like terms underneath one another. So when negative 1 times x cubed is multiplied, I get negative x cubed, then negative 2x squared, and minus x. So then from here, I can go ahead and combine like terms, which is adding. So I get 2x to the power of 4 because it has nothing else to combine with, plus 3x cubed. Notice how your x squares cancel. And then I get minus x. Now, a friendly reminder, because I know this happened on the quiz, notice how I did not add my exponents. I'm not doing that. I only add the coefficients. So then in number 3, this is a special case because I see two binomials. They are the exact same except for one is minus and one is plus. So I know that that's the difference, or the sum and the difference of a binomial. And so that's the formula a squared minus b squared. So that would simply be 9x squared minus 1. Now for number 4, I'm squaring the difference. So I know that that's a squared minus 2ab plus b squared. And so if I were to square the a value, that would be 100x squared minus, and then I'm going to multiply the inside numbers, so that would be 80x, double it, and I get 160. And then I'll square 8 to get 64. And then number 5, I'm squaring the sum. So that's a squared plus 2ab plus b squared. And so when I square my a value here, that would be 49x to the power of 4 plus, and then I'll multiply 7x squared and 5, so that's 35. And then if I double it, that's 70x squared, and then I will square the 5. Now number 6 is nothing fancy. I cannot take a shortcut, so I'll have to distribute the x. So I get 2x cubed minus x squared plus 5x. And then I'll go ahead and distribute the 4. And so that's going to give me 8x squared minus 4x plus 20. And then from here I can go ahead and combine like terms. So I get 2x cubed plus 7x squared plus x plus 20. All right, number 7, I notice it's a special case because I've got two binomials that are the same. One's minus, one is plus. So that's the formula a squared minus b squared. So that would give you 25w squared minus y squared. Now number 8, I'm squaring the difference. So that's a squared minus, whoops, let's undo that, 2ab plus b squared. So if I square my a value, that would be 9t squared minus, I'll multiply those two together to get 12t, and then I'll double it to get 24t, and then plus 16. And then finally, another special case, I've got the squaring of the difference, so a squared minus 2ab plus b squared. And so when I square my a value, that would be 81q to the power of 6 minus, now 9q cubed times 3s would give me 27q cubed s. Then I have to double it, and that would give me 54q cubed and s. And then I will square the 3s to get 9s squared. And that is it.